6.2 Trig ratios. Again, we're looking back to grades 10 and 11 math. This should be a review for you. Trigonometry is a branch of mathematics that studies triangles, and more specifically, right-angled triangles. Trigonometry deals with the relationship between the sides and the angles of the triangles. From a functional point of view, trig allows us to measure inaccessible and difficult to measure objects. For example, how tall a tree is, how tall a building is. It is used in surveying, construction, navigation, engineering, physics, and astronomy. Let's start by considering the parts of a triangle. A triangle has 3 sides and 3 angles. Let's start with the easy one, the 90 degrees. This is the 90 degrees that makes our triangle a right angle triangle. We've got angle A, we've got angle B. Notice how they're labeled outside of the angles. We'll call the 90 degree angle C. So our 3 angles are A, B, and C. Our sides, we'll label them with lowercase letters. So our angle C, we're going to go across through the 90 degrees to get to side C. A, this is angle A. We're going to go across through the triangle to get to side A. B, we're going to go across through the triangle to side B. You'll notice that in each case we've gone across and through the triangle to label our sides. Angle A, angle B, angle C. Side A, side B, and side C. There are 3 trig ratios. There's the sine ratio. Sine of the angle equals opposite over hypotenuse. There's the cosine angle. Cos of the angle equals adjacent over hypotenuse. And there's the tangent ratio, which is tan of the angle is opposite over adjacent. Now these words, opposite, hypotenuse, and adjacent, they're all dealing with sides. The angle is one of the 2 angles in our triangle that are not 90 degrees. The labeling of our triangle is unique to its side. If angle A is the angle I'm dealing with, then all my labels are off of angle A. We start by labeling the most obvious, the hypotenuse. We saw in the last lesson, hypotenuse was our longest side. Visually, you can see that this is our longest side. It also may help you to say, go to your 90, go across the triangle to my hypotenuse. Now for angle A, we need to label an opposite and adjacent. I like to start with my opposite. I start with my angle, go through the triangle, and get to my opposite side, leaving my last side adjacent. Adjacent you may think of as touching your angle. Touches the angle. Now if I was to change this up and have B as my angle, clearly some sides will change. The hypotenuse would still be the same, but if I go to my opposite, it comes over to here, and my adjacent would come to A. So depending on the angle you're using, your labels will change. Let's try some examples down here. Find the sine of angle A. Well, this is A. We know the sine is opposite hypotenuse. So the first thing we do is label it. Here's my 90 degrees. The box jumped up a bit on me. But I know across from my 90 is the hypotenuse. For angle A, go across the angle for the opposite. And for angle A, the remaining, touching, is adjacent. So sine of angle A. Sine is the opposite over hypotenuse. Well, what's my opposite side? My opposite is 4. My hypotenuse is 5. So the sine of angle A is 4 over 5. Let's try this with cos. Cos of A. From my formula, I know that cos is the adjacent over the hypotenuse. My adjacent is 3. My hypotenuse is 5. So cos of angle A is 3 over 5. Finally, let's do this with tan. Tan is opposite over adjacent. So my opposite from my diagram is 4, and my adjacent from the diagram is 3. So I've got sine of angle A is 4 over 5, cos of angle A is 3 over 5, and tan of angle A is 4 over 3. Now let's do the same thing with angle B. We must make sure we erase our labels. Quick erase, gone, and now we're looking for angle B. So if we label angle B, start with hypotenuse. You'll notice that one has not changed. It's still the longest, it's still across from C. Start at angle B, go across my triangle, gives me my opposite. And the last one is the adjacent. So you can see that when we switched from A to B, our opposite and adjacent has switched. How is that going to affect our ratios? Well, sine, opposite over hypotenuse. My opposite is now 3, my hypotenuse is 5. So it's 3 over 5. Cos of B. Well, my cos is adjacent over hypotenuse. My adjacent is 4, my hypotenuse is 5. 4 over 5. And finally, tan is opposite over adjacent. 3 over 4. You can see if we compare A's to B's that sine and cos has simply flipped. And my tangents have also flipped. So this is how we take a triangle, label it, and get our ratios. Now let's take a look at how to actually solve for angles and sides. So we have some instructions here. Determine the angle which is being used. Okay, well, example 1, it's 25. So it's angle Z. Label the sides as opposite, adjacent, and hypotenuse. Well, I'm going to start with my 90, go across. My longest is the hypotenuse. I'm going to go with my angle, go across to get my opposite. And that will leave me as 12 as my adjacent. Now decide on the correct ratio to use. So before we do that, which side are we solving for? Well, the question actually asks us to solve for the y and the x. Which one do we want to do first? Or sorry, z. Which one do we want to do first? Let's do z first. So if I'm solving for z, I need to have my opposite. Which other side do I know? Well, my hypotenuse is my y, and my adjacent is 12. So I know my adjacent. Now, a word you might have heard of back in grade 11 is SOHCAHTOA. Make sure that you spell it correctly. This little word will allow you to choose the right formula. I'm looking for my opposite, so my O, and I have my adjacent. So I'll go to our word. Which has the opposite and the adjacent? No. No. Well, yes, it does. So T stands for tangent. So tan of my angle equals the opposite over the adjacent. So step 4 says write the correct formula. Done. Step 5, input my information. So my angle is 25. So tan of 25 equals my opposite. I don't know what it is, so I will keep it as z, over my adjacent, which is 12. At this point, we need to solve. Pull out our calculator. I'm going to turn it on. First thing I have to do is calculate the tan of 25. Now again, each calculator is slightly different. On this one, I'm going to hit the tan button first. And you can see my display says tan and a bracket. I'll place my angle, 25, close my bracket, equals. So the tan of 25 is 0.466307658, and that goes on for a long time. In terms of accuracy, when you're working within your formula, we want to use the first 4 numbers. So that's 0.4663 equals z divided by 12. Now we want to solve for the z. Right now it's being divided by 12, so I'm going to multiply by 12 to get rid of it. Whatever I do to the right, have to do to the left, times this by 12. So my answer, I'm going to take 12 and times it by 0.4663. 12 times 0.4663 equals 5.5956. So we're going to get an answer of 5.6 with rounding. So that was the answer for z. We still have to do y. So let's look at y. Y has my hypotenuse and my adjacent. Which has hypotenuse and adjacent? Well, it's the cos. Cos of the angle equals the adjacent divided by the hypotenuse. Let's substitute in. Cos of 25 equals 12 over hypotenuse, which is y. Now we have a little problem, as our denominator is what we're solving for. With a little bit of fancy math, we can just simply switch these guys around, and we haven't changed anything mathematically. So y is going to be 12 divided by the cos of 25. Let's go back to our calculator. Cos of 25 is 0.9063. So y equals 12 divided by 0.9063. Clear our calculator. 12.9063. Y equals 13.24. Now these guys both have units of meters, so our answers should have meters. Let's look at our second example. Example 2, we've got a triangle. It's right angle. First thing we do is find angle T. So in this case, this is our unknown, angle T. Let's label our triangle. Start with our 90, go through it to get the hypotenuse. Start with the angle, go across to get the opposite, which leaves the adjacent down here. Now we're looking for angle T. In this case, we need to have the known value for two sides, so the opposite and hypotenuse. If you remember SOHCAHTOA, which formula deals with the H and the O? It's the sine. So sine of the angle equals the opposite over hypotenuse. Plug in what you know. Sine of the angle is 5 over 11. Let's now take 5 over 11 down to 4 decimal places. Pull out our calculator. 5 divided by 11. 0.454545. So sine of the angle is 0.4545. Now in this case, to get the angle, we need to do the inverse of sine. So if we look to our calculator, above our sine button is sine -1. So we clear our calculator. Second function, sine of 0.4545, close the bracket, equals my angle is 27.03, so 27 degrees. So you can use SOHCAHTOA, trigonometry, to find any angle or any side.